If we look at this study, this is a PET scan. It's very similar findings where they had typical children listen to a tone or generate a sentence, and they got an increase in blood flow to certain areas of the brain on PET scan. And what they found in the autistic children was that actually the blood flow went down. So it went the reverse direction. If you look at this study here, this showed, in this study, 86% of the children they studied with autism had decreased blood flow compared to typical children. I'll blow this up for you. The decrease in blood flow was not dramatic, okay? It was about 8% less, but it was statistically significant. So what we're finding, and this is a different study, just showing decreased blood flow, especially to temporal lobes in autism. And if you start looking at where the decreased blood flow is in the temporal lobes, it connects to your auditory and visual processing centers. Interesting thing is, as the age of the child gets older, the blood flow diminishes further, so it becomes quite profound the older that you get. And this is in your handout in the book, okay, so as a table. Basically, if you start looking in literature, there's dozens of studies correlating decreased blood flow to certain areas of the brain with clinical symptoms. So if you take Wernicke's area here, which is involved in language, if you have decreased blood flow there, you tend to get decreased language development. So you can see that if you have an area that's underperfused, maybe not getting enough blood flow, you're going to have a little bit decreased oxygen, a little bit decreased sugar perhaps, and this correlates with their symptoms. Now, no one has really stopped to say why do they have decreased blood flow. It's just documented in literature. It's kind of like they're just reporting it. This is from a study out of Johns Hopkins in 2005, published by Vargas and her associates, showing inflammation around the blood vessels in a subset of autistic children. They took 11 children who died natural causes, looked at their brain under the microscope, and found inflammation. So you can see where this arrow is. There's inflammation surrounding the blood vessel. Normally the blood vessel should look like that, where it has a very thin wall. It doesn't have inflammation around it. And so if you start looking in literature at diseases in which you have inflammation in the brain, if you look at Sjogren's, Behçet's disease, encephalitis, Kawasaki's disease, lupus, these are all diseases that have inflammation in the brain that can cause decreased blood flow. So if you look at the study here, this is actually a Spec Scan, and the blue arrow here shows the scan at baseline and then after an intervention. And the areas that are in red are areas of increased blood flow. The areas in green are decreased blood flow. And you can see an improvement in blood flow after the intervention. Now, what you might think is, wow, that's hyperbaric oxygen doing that. What this was an anti-inflammatory medicine. So they gave the people an anti-inflammatory medicine, they got improvement in blood flow to the brain. And then we're going to talk about inflammation of the brain. So this is the study that I alluded to from Vargas out of Johns Hopkins, published in 2005. And what they found is that markers of inflammation were higher in the brain of autistic children compared to typical children. Things like MCP, IL-6, these are just markers of inflammation. And when they looked at the brain, the one on that's marked A is a typical child, and you can see how that looks. And then if you look at the B, that's an autistic child, and they have a lack of, or a loss of Purkinje cells, which is at the orange arrow here. And at the blue arrow, they have a loss of the granular cells. So you can see, you don't have to be a doctor to see a difference in the brain of the autistic child compared to the typical child. This is a blow up. The areas that are staining in brown are actually inflammation in the brain. On the bottom slide, which is marked G, that's the green areas are areas of inflammation as well. And so we go back to this. What we think is possibly happening, we don't know for sure, is that the decreased blood flow we're finding in some of these autistic children may be due to inflammation. And you can imagine if you have a blood vessel here that's thicker than it should be, maybe it doesn't dilate like it's supposed to, and you won't get an increase in blood flow. So you can imagine if you're doing speech therapy or whatever therapy you're doing to try to improve speech, but you're not getting adequate blood flow to a certain area of the brain, you may not have an optimal outcome. This is a very interesting study published in 2004, basically looking at functional connectivity. And if you look at the bottom, this is looking at functional connectivity in a typical child. What functional connectivity is the way that one cell in the brain talks to another cell. And you can see that it matches up pretty well in a typical child. If you look at the top slide, the signal that goes from one cell, and then when it shows up in another cell, there's a gap in the middle there. And so it appears in autism, at least, that the cells are not communicating as well as they should be. And certainly if you have inflammation in the brain, it typically will cause a little bit of increased swelling. There's now 2 studies in literature published in 2006 looking at special MRI scans where they found increased water inside the brain of brain cells of certain children with autism. And so what we think is happening is the inflammation that's in the brain is leading to decreased blood flow, leading to problems with cells communicating with each other, perhaps causing a little bit more water inside cells in the brain. How do we measure that? One of the tests that you can do is something called Neopterin. When you tend to have a lot of inflammation in the brain, Neopterin will go up, and you can measure this in the urine. There's now 2 studies in the literature. This is one of them looking at Neopterin compared to typical children, Neopterin in autistic children. And you can see in orange here that Neopterin levels are higher. So when you have a lot of inflammation, the Neopterin level will tend to go up, and it's just a screening test for inflammation that we often use in clinics. So when I see a child that comes in, we'll get a urine Neopterin level. If it's elevated, and we'll know that there's some inflammation. The higher it is, there tends to be more inflammation. So the higher it is, it helps us to know that the inflammation is present, and then we can do an intervention, i.e. anti-inflammatories or something else to bring the inflammation down. If you start looking at the blood of autistic children and look at what the antibodies they make against brain tissue and blood, you can see here that about 35 to 40% of children with autism will actually make antibodies, IgG, IgM, IgA antibodies to gluten, and they'll also make antibodies to the cerebellum. One of the things that's important to know is that the Purkinje cells of the cerebellum share an 8 amino acid sequence with gluten. And so in celiac disease, which is allergy to gluten, these antibodies can cross over into the brain and cause psychiatric problems, even schizophrenia. If you take the wheat away from people who have celiac disease, their neurological or psychiatric problems go away. And so one thing that we think is happening in some of these kids is they're making antibodies to gluten, which then can cross over into the brain and attack some of the brain cells. And that's one of the reasons we recommend the diet. Oftentimes when I have a child that comes in who is not on the diet or mom's afraid to do it, Shannon, we'll measure antibodies to gluten to make sure that they're not making them, because then the diet really becomes maybe more of a medical necessity, because we just don't know if these antibodies are crossing into the brain or not. If we start looking at other studies looking at inflammation in the brain or in the autistic child, if you start looking at just markers of inflammation, so autistic children compared to typical children, you'll find things like interferon gamma, IL-10, tumor necrosis factor alpha, IL-6. These are all markers of inflammation, and they're higher in children with autism compared to typical children. This is just from blood work that we can do. This is a very interesting study that was published in 2005, and what they looked at was something called isoprostane, marked here in orange, and they found there was much higher in autistic children compared to typical children. What this can do is lead to vasoconstriction. Vasoconstriction is where you get the blood vessel that clamps down and maybe you don't get as much blood flow. And so you can see marked elevation in isoprostane compared to typical children. Again, this goes back to everything you've been hearing this morning about how autism is more than just a psychiatric condition. If you start looking at this study, this is looking at oxidative stress, and what they found was that thromboxane, which is here in orange, was higher in autistic children compared to typical children. Thromboxane can lead to platelet aggregation, which means platelets can stick together and it can decrease blood flow. They also found that prostaglandins were higher in autistic children compared to typical children, here in orange as well. And this can lead to endothelial activation. What that means is that the lining of the blood vessel becomes sort of sticky, and that can also lead to decreased blood flow as well.